Hey guys, it's Solbyte, and today I'm going to be going over algorithmic complexity. All right, and this is going to be my very first video in my algorithm series. I figured that I would do some algorithm tutorials alongside the data structures tutorial because, um, data structures and algorithms kind of go hand in hand. I mean, oftentimes they're actually taught together. I mean, if you look up a data structures tutorial, chances are one of the very first results is going to be actually a data structures and algorithms course instead of just a purely, data structures course. So yeah, today I'm going to be starting my algorithm series, and I'm just going to be doing it alongside data structures. That way you guys can kind of follow along and have everything that you need for the type of data structures that we're going to be implementing in the future. So anyways, what exactly is algorithmic complexity? So there's some more formal definitions out there, but the way that I like to think about it is it's basically how slow an algorithm is depending on size n. And size n typically refers to of the input for the algorithm to process, right? And this matters a lot, algorithmic complexity, because for example, you can have two different algorithms that solve the same problem, right? They do the exact same thing, they get the same output. However, one of them might be quicker and more efficient than the other, right? So understanding the theory of how complexity works, how algorithmic complexity works, is very crucial in that sense, because for just a very simple algorithm, if the input size is doubled, then how will the runtime be affected, right? Will the runtime be doubled? Will it be quadrupled? Will it? I mean, will it be factorialed? I mean, there's so many different complexities that kind of represent how input on a specific algorithm, depending on how you've implemented it, can really, really like just totally crash your program or just make it incredibly slow to where it's just not efficient at all. So it's really, really important to understand algorithmic complexity, and we will go over how to kind of calculate complexity. We'll go over the different types of complexity, and we'll go over big O notation and all this kind of stuff in a future video. But today I'm just going to kind of introduce you guys to what exactly I mean by algorithmic complexity. And a good way of thinking about it is this is just kind of an example. If the input size increases from 1 to 10 to 100, then the linear runtime, and these are representing seconds. So let's kind of denote that really quick. For a linear algorithm, one that has the complexity of just n, then it goes from 1 second to 10 seconds to 100 seconds as the input increases. It doesn't have to increase at the same number. This is just kind of how I wrote it. But for a complexity that is quadratic, right, then as the input increases, the runtime increases significantly, right, quadratically. So yeah, so this is kind of a very simple way to think of it, and I'm actually going to show examples of both linear and quadratic runtime, or sorry, complexity down here. So let's do a very simple example. We have one array, just a very simple array of 5 integers. And we have a vector that is basically kind of acting as a 2D array. And I'm going to just kind of show you guys how two different algorithms that represent linear complexity and one that shows quadratic complexity. So the example for a linear algorithm, or an algorithm, sorry, that represents a linear complexity would be just like a simple for loop iterating through a simple 1D array and outputting the values. So we'll just kind of go ahead and make that really quick for ourselves, and just very simple. I'm sure you guys have seen this before. We will just see out the value at whatever the index is, and then indel. All right, so this basically is representing a linear an algorithm that has a linear complexity, right? So basically, as the input increases, as we fill up this array with even more data, then the runtime will increase linearly instead of quadratically, or God forbid, factorially. So very simple, very kind of easy complexity. And I mean, I can go ahead and kind of just show you guys that it does work, I guess. What did I do? Oh, yeah, I forgot to, sorry. There we go. So yeah, let me go ahead and compile this actually. And just to, just to kind of have it see out and represent it actually being able to work. So yeah, 1, 2, 3, 4, 5, perfect. All right, so now let's go over an algorithm with a quadratic complexity. So we're gonna do this in the form of a nested loop that will output the values of this 2D array. So we're gonna do int I equals 0, and then we're gonna do this, and what we want to do here is we want to get the size of the vector, and then I++, and then we'll do another for loop after that. So we'll do int j equals 0, and then for this one we will check I think it's int v, and then we need to do the current index size. Should be right on that. It's kind of a looks like a sloppy mess, but trust me, pretty sure it'll work. Pretty sure it'll work. I never know with myself. So now we'll just go ahead and see out the values of each. So let's do we'll do v I and j, right? And then we'll do indel. All right, so let's go ahead and check out and see the results from this. Go ahead and comment this out for right now. That way our terminal is a little clear. All right. Oh wait, my apologies. I used I++ instead of j++ on that one. Okay, let's see if this works. Like I said, you never know with me. All right, perfect. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, which is exactly what is in our vector. So perfect. So yeah, this if we increased the input size of for this algorithm, then the runtime would increase quadratically. It would increase so much so that you would definitely notice. So that's kind of basically what I mean by algorithmic complexity. And we will go over the different types of complexities, like I said, as well as the most common types, like the big O notation, because that's a very important concept when it comes to computer science and just theory in general. So yeah. But this is a very good starting point just to kind of help you understand the kind of overall idea behind algorithmic complexity and just complexity in general. And it'll really kind of set you, get you a good foot, a good start going forward in our algorithm series. And then eventually, we'll get to sorting algorithms and all types of stuff. So yeah, but anyways, if you guys have any questions, please let me know in the comments below. I'm going to add some references to these to the description. Sorry, I can't speak today. I'm going to add some references to the description and probably include a little bit more, including some that kind of go over big O notation as well, just to kind of, because it's a very simple concept, but usually in most of my videos, I kind of do the implementation of something like that. I don't really do too many like graphs or like, visual like examples. So if you guys want to go and check those out, please feel free to go and do so. And yeah, that's about it. So thank you for watching.